Alright, I guess technically it's off to the right. It's not below, but who cares about that? I want to find the area for that region. Okay, so a couple of different boundaries here. We've got the x-axis, we've got the y-axis, we've got this curve f of x, we've got this other curve g of x, and I need to find the area. This is like the new thing. This is what we're doing these days in calculus class. Somebody tell me, what are some of the problems you ran into? What are some of the issues? Edgar.
I guess, you know how we have to subtract one function, but we got to put one first?
Yeah.
Because we need to see which one is above. I got confused between that. Like, which one do I put first?
Okay, so some confusion about which one do you go first, which one's on top? Great questions. The answer is draw the rectangle. Draw that little slice. I'm going to say this, I was talking to one of the calculus teachers this morning. The whole story is in this rectangle. When I look at what Riemann would tell me, Riemann says draw your little rectangle. Well, if I draw a rectangular slice here that has a thickness of dx, my question to you guys is how tall? How tall is that rectangle? This is not the hard question. It goes from the x-axis up until this curve. How tall?
It would be f of x minus g of x.
It's not f of x minus g of x. If you're thinking top minus bottom, f of x is the top function, but what's the bottom function? 0. Y equals 0 is the bottom function. The height here is just f of x, or f of x minus 0 if you want to. That's the length of the slice here. If I made the slice here, what's the height? It's still f of x minus 0. What if I made the slice here? Same thing. Is it always that way? There is a place where it changes. The place where that changes is right after here. So from like, what is this, 0 until whatever this is, let me call that a, the height of the rectangle is always top minus bottom, f of x minus 0. So my setup, I'm just going to say, oh, it's an integral from 0 to a of f of x dx, plus now I've got to think about what happens after this point. Well, what happens after this point? Adriana, do you have a question or a thought?
No, so like when the functions, like they intersect, so you're no longer using the y x-axis.
Yeah.
So does it go f of x minus g of x?
So like this little slice over here, is that what we're talking about?
Uh-huh.
Okay, how tall is that? How long is that slice? It's top minus bottom. So the top function is f of x, the bottom function? G of x. But it's f of x minus g of x only after you pass this root over here, and it continues being f of x minus g of x until you hit the intersection point over here. So you would do an integral f of x minus g of x dx from a to b, and of course on my calculator I'd have to figure out what's b and what's a. Those slices tell the whole story. I have nothing else to teach you other than the slice. And the way I did it, I said, let me think about a slice over here. Easy enough. What about over here? Are all the slices the same? Are they always same top function minus same bottom function? If they were, easy, but because it changes over here at this root, you're going to have a second integral. What other questions are out there? All the friends are okay? Giselle?
On the key, you have g of x minus f of x.
I have g of x minus f of x? Oh,
Yeah.
how awkward. Shameful. But we're clear. It should be f of x minus g of x? Everybody's okay? Everyone's ready to put their money where their mouth is?
No.
Then you must have a question. I told you you're going to get graded on something this period, and it wasn't the homework. Now's a great time if there's anything you're not sure about. Noemi.
So y would equal...
Look at all the hands now. They're here. Yeah, Noemi.
So the height will equal 0 only when the y, when it's touching the
The height is not 0. The height is always determined by top function minus bottom function. In this case, the bottom function is the x-axis. Top minus bottom, top minus bottom, top minus bottom. It's just that over here, the top and the bottom are not the same as the top and the bottom over here. Jennifer. Wait, one more time? Yours is a personal question. Okay, good luck with that. Okay, Daisy.
How did you decide where to plot the points A and B?
Okay. The significance of A is where this graph of g of x intersects the x-axis, right? Because it's at this point A that when I start talking about my slices, it doesn't go from f of x down to the x-axis, it goes from f of x down to g of x. That's why A is important. Why is B important?
Because it intersects with f of x and g of x.
It's where f of x and g of x intersect, but it's as far to the right as I'm going to go in my shaded region. Okay. Everybody's good? Jennifer?
If it was in calculator inactive, how would you find what A is?
You'd be doomed. These are not friendly functions for calculator inactive. But don't worry, I know how to choose them. All right, good enough. So Mariah and Anthony, based on that, like 6 or 7 minutes, you are going to do the best that you can on this formative assessment. Breathe. You have 5 minutes. This is not the thing you are being graded on. If somebody would like to adopt Mariah for 5 minutes and help her out. Wow, that's how it works here. Nobody's willing to help Mariah out. Fine. She's going to get you later. Anybody willing to adopt Anthony for 5 minutes while you work on this formative assessment with him? Nothing but haters in the room. They're afraid of you all. No, we're good. Okay, 5 minutes. Everyone on their own, no help from anybody. Mariah and Anthony, if you guys go over to the side table, I will adopt you all. This is your nightmare come true, I know. Anthony wants to put himself up for like readoption. Yes, this is where Jesus comes in. Okay. 5 minutes, calculator active, no help from any of the friends. You got this. Hi, friend. That would not be such a bad idea. In fact, hold on. I want to see your calculator setup. I want to see all the things. good things to do. I would be graphing this function. I would be shading this region. I would be figuring out what exactly is the region we're talking about and setting up the integral. All right, Marvin, we're coming over to you here. We are. All right, region that I'm interested in says bounded by f of x equals natural log of x minus 3. The line y equals -1 and the line x equals 8. So if here's y equals -1, here's the curve, here's the line x equals 8. From all the folks that I visited, that's the region. Is everybody 100% on the identification of the region? Everybody's good? David?
How do you draw x equals 8
On the calculator, good question. I wouldn't worry about drawing the line x equals 8. That's not as important. It's just a visual for you right now. The key is, though, how do I find the area? I want to go back to the slice. Draw me some slices. If I'm going to slice my rectangle this way, this way, this way, what's the height of each slice? Not f of x, nope. Every single slice ends on the curve f of x and goes all the way down to where? Y equals negative, is it -1 or -2? -1. So your setup, if I want to know how tall the rectangle is, it's going to be f of x minus -1, or even better, f of x plus 1. So your integral, you're going to integrate f of x plus 1 dx. Having that integrand correct, I'd say gets you the first point. Now I'm interested in the limits of integration. What are the limits of integration going to be? Edgar.
Well, one of them is 8 because we know that x equals 8.
Right. The important thing, David, is that we know the vertical line x equals 8 even if I don't draw it. Okay. Now that's going to be my upper limit of integration. The other one?
Wouldn't it be 3.37?
Okay. Now you got to be really careful there. It sounds like you're in the wrong mode.
A.
It has to be 3 decimal places all the time. So check your settings. It should be 3.367. Okay. So I'm going to go from A to 8, but you have to tell me A is 3.367. Marvin, if you could remind the folks how to store that. Do you remember how to store it? Right. So let it turn into a hand. Var. Okay, wait. Escape. Escape out of the whole thing. Escape. Move over to the point one more time. So it's a hand. Once you're there, click on it once. Var. Store var. Now call it something. M for Marvin, A for awesome, whatever you want to call it. Now hit enter. Shows up in bold. Okay, I would say probably on a problem like this, getting your limits of integration correct gets you another point. Last thing I need to see, Marvin, can you get us the integral? Right, calculus, numerical integral, and then everything you just wrote down, just type it in. That's it. You're going to go from A to 8, and then f1 of x close your parentheses, then plus 1 dx, and according to Marvin's calculations 8.415. Honestly, how many guys have 8.415? We are in a very good place. I care greatly about the integrand. You're going to get that by identifying the region and looking at the slices. I care greatly about your limits of integration. You're going to have to understand the region. And I care greatly about the number. That's the final point. Everybody's good? All right, now it's time for a challenge. And Ryan, Anthony, you guys need to join us for this. We're going to do this problem 2 more times. Next time, we're going to do it without the calculator, which was somebody's question from earlier. It's exciting, I know. It's exciting. Marvin, you can return to the land of the living. Leave yourself enough room. We're going to do this problem 2 more times. All right. So, no calculator will be used for anything this time through. We're going to go like old school, which is the school that I went to. All right, let R be the region defined as the section of the xy plane bounded by the curve f of x equals natural log of x minus 3. The line y equals -1 and the line x equals 8. Determine the area of region R. They don't even give you a graph. Nothing is provided. But I chose a friendly function. I did. Natural log of x minus 3. What does it look like? Okay, good. Everyone's like doing the right thing for natural log. But if it's natural log and then x minus 3, shift. Good. So right now we're just setting this up. Natural log would pass through the point 1, 0, but I go 1, 2, 3 to the right. Natural log has a vertical asymptote here. It's now going to have a vertical asymptote at x equals 3. Log passes through the point 4, 0. There it is. I also expect that you know that the line y equals -1 is down here, and the vertical line is x equals 8. Like, these should be things that we are comfortable with. Region that I'm interested in, right here. I'm doing all the things, no calculator. Next move. We just did this problem. Everybody knows the next move. What's the next move?
They define the points of integration.
Maybe you want to focus on the limits of integration. The thing I would focus on next is that slice. Think about what Riemann does. Riemann starts chopping up the region. So if I make my slice here, here's my rectangle. The questions I'm going to ask you are, how wide is this rectangle? How wide?
dx.
dx, right? The dx is that variable thickness. We're going to let dx be small. I'm going to ask you the question, how tall?
No, f of x minus y.
Right, f of x or y, you know, same thing. We'll be friendly here. It's Friday before spring break. Top minus bottom. So it's natural log of x minus 3 minus negative 1. Okay, not too bad. So my area expression over here is going to be the natural log of x minus 3 minus negative 1 dx. I'm integrating with respect to x. Other things we need? Jennifer, what else you need? The points of intersection. No calculator is allowed right now. One of these is easier than the other to get. Right? We know it ends at x equals 8, so that's your upper limit of integration. Now, here's the problem. How do you find this one without your calculator? Talk to somebody near you. What's your plan? No calculator. What are you going to do?
Which one?
No, yeah. I think that is what it is.
Zeros after you implement it.
I think we
What's so special about this intersection point is that two curves come together. Specifically the graph of the natural log of x minus 3 and y equals negative 1. I'm not looking for roots, I'm looking for intersection points. So, set them equal to each other. Natural log of x minus 3 equals negative 1. I need the x value. There once was a time in your lives where figuring out a problem like this would be really hard. But everybody knows how to get to x. Right, you okay here? I'm the good looking guy over here. Edgar, how am I going to figure out what x is?
You exponentialize, so you're going to take off the natural log?
I'm going to exponentiate both sides. God, it was exciting when you said that.
Oh.
Those cancel out. X minus 3 equals e to the negative 1. X is equal to 3 plus e to the negative 1. I do not know what 3 plus e to the negative 1 is, and I don't want any of you to worry about knowing what it is either. That's not important. What I care about, though, is that's my lower limit of integration. 3 plus e to the negative 1. You're going to get a point if you have the integram correct. You're going to get a point for the limits of integration. We're about to get stuck. Big time stuck. Anybody know the antiderivative of natural log of x minus 3? That's the derivative of the natural log of x minus 3. Antiderivative of natural log of x, for any of you that have your foldable handy, does not show up in that foldable anywhere. You know how to find the derivative of natural log, and you know what to integrate to get to the natural log. So right now I'm just going to say that we're stuck. That is the word stuck. Apparently, Calc BC, the first time I wrote that, they thought I was integrating something. For reals. We are stuck. That is a T. But I'm curious.
Oh.
That's because you're a good girl. All right. Are all the friends okay with, like, I can set up the region, I can set up the integral. Unfortunately, we don't know how to find the integral, find the antiderivative. So here's the new idea. Here's the third approach to this problem. You're going to love it. We're going to take what Newton did and turn it on its side. Not Newton, Riemann. So let's redraw the diagram. No calculator. X equals 3. You're going to love it. This is going to be the high point of your week. For real, Mariah. Fake it till you feel it. Y equals negative 1. X equals 8. I have a new idea for you. Riemann said the way we're going to find the area is we're going to do slices. He never said that the slices had to be vertical slices. What Riemann said was do slices. So I want to turn this problem on its ear. Rather than making my slices this way, we're going to make the slices that way. Make sure you get the slice. I am turning everything on its head. Jasmine, stay with me. You can do this. Those are my slices. I want to think about slices going all the way up and slices going all the way down. We're going to add up the area for every single slice, not going left to right anymore, but from bottom to top. This is going to be, we're going to call these the horizontal slices. We have never before done horizontal slices. We have only lived in a vertical slices world. Good news, there's more to the world. So here are the things that change. Everything changes. Everything changes. If we go back over here to the vertical slice world, the thickness of the rectangle was dx. And we did an integral in terms of x. The integrand was in terms of x. The limits of integration were in terms of x. All the things, dx in terms of x, x values. In a horizontal slice world, everything is in terms of y. Every single thing. Stay with me one. The thickness of this rectangle is now dy. The length of the rectangle is going to be in terms of y. Over here in our vertical world, we did top minus bottom to figure out how long. Over here, we're going to do right minus left to figure out how long. It's all the things we did, you're just working sideways. So, here's my dy integral. We can either have conversation about the length of the slice or the y values for the limits of integration. Before we do anything else, what questions are out there? Excellent. I'm hoping to blow some minds. Honestly, if you can do the vertical slices, this is probably 80 to 90% of the problems on the AP exam. And for some of you, you're like, Coach, that's good. 80 to 90%, I'm taking that paper home, putting it on the refrigerator. This is like the bonus innings, but this is also the direction the College Board is moving recently. And I want to make sure that you're ready for this. So stay with me. I'm doing my integral with respect to y. I need to know what's the function on the right. What's the function on the right?
X equals 8.
X equals 8. What's the one on the left?
Natural log.
If I do right minus left, I'm going to say it's 8 minus the natural log of x minus 3. Here's the problem. I'm doing a dy integral. I need to treat y like it's the variable, not x like it's the variable. But good news. We know that y is equal to the natural log of x minus 3. So instead of talking about this curve as y equals the natural log of x minus 3, I'm going to solve this for x. And you guys know what to do. We're going to exponentiate. Those cancel. E to the y equals x minus 3. X equals e to the y plus 3. We're still talking about the same curve on the left, but when I do right minus left, rather than saying 8 minus natural log of x minus 3, I'm going to say it's 8 minus e to the y plus 3 dy. That's the length of the slice. You might want to do a quick scan. If I do a slice up here, is it the same right and left bound? Down here? All the way up here? Everywhere I draw my slice, same right and left bounds, which is a good thing. So I've got my integrand with respect to y. The only thing left, need the limits. One of these is easy. This is easy one.
-1.
Right, I'm going to, 8.
Oh no.
-1. It's a dy world now. You start down here at y equals -1. That's the easy one. And now you got to figure out this guy here. right? What I need is the y value. And I heard Marvin say plug in 8. We know x is 8. What's the y value? Natural log of 5. Whatever that is the number, don't care. Right? Leave it natural log of 5. You've got your integrand. You've got your limits of integration. Look at the integrand. In the level of difficulty here for finding that antiderivative, this should be a comfortable one for everybody in the room. You know the antiderivative of 8? 8y. Antiderivative of e to the y? E to the y. Antiderivative of 3? You've got all the things. You avoid this roadblock over here if I don't know how to integrate, and you wind up with a friendly function over here to work with. So let's just finish this off real quick. Okay, y equals negative 1 to the natural log of 5. 8 minus all that, I'm going to distribute. 5 minus e to the y dy. Antiderivative of 5, 5y. Minus antiderivative of e to the y is e to the y. Go from y equals negative 1 to y equals the natural log of 5. I know I'm going fast on this part, but this should be pretty straightforward. Find the antiderivative. Next move, plug in your limits. So you've got 5 times the natural log of 5 minus e to the natural log of 5 minus, plug in the negative 1. 5 times negative 1 is negative 5 minus e to the negative y. And if we're on the free response part of the test,
Stop.
are they all numbers? Is every single part a number? Then you get to stop. Where do you see something
Just
that's not a
the
number?
negative 1.
Ah! Oh, we're going to have to edit that film out of the film. Okay, is everything a number?
Yes. Okay.
So we could stop here. Or you could show off and simplify. You're like, don't do it!
Don't.
There's some simplifying here. Some good simplifying. E to the natural log of 5
5.
is 5. So the most simplified version that I can think of is 5 natural log of 5 minus 5. Distribute that. Plus 5 plus e to the negative 1. Those cancel. And you get 5 times the natural log of 5 plus e to the negative 1. And for all my friends that are really curious, type 5 plus natural log of 5 plus e to the negative 1 into your calculator.
What's going to be the answer?
415.
It's what?
8.415.
8. Is that a familiar number?
Yeah.
It is the exact same answer as you did earlier with the calculator. Do not freak out and think, oh my God, I had area yesterday, now I don't have area. This is just that next push. Are all the friends mostly okay? In a little bit of shock and awe right now.
Yeah.
That's fine. All right, so here's the plan. You've got the next 18 minutes to earn above 100 on a homework grade, working with one partner and only one partner on the next 6 AP problems. If you get all 6 of them done between now and 2:09, you get 110 on a homework grade. You get one partner and one partner only. If you get 5 out of 6, I think that's going to be about a 90. Still not a bad grade. Pick your one partner. It doesn't have to be somebody that you're working with right now, but it can only be one. Does everybody have their partner? I see Juan letting his eyes do the talking. Apparently it's not Jasmine. She's like, she doesn't know the calculator yet. Just saying. Yes. Okay. 15 minutes. You and your one partner. You can check in with me twice in the next 15 minutes. Go. Jose, it's your birthday. I'll let you stay with these two. You chose yourself. stay with them. It's your birthday. Get yourself a good day.
Can I stop recording?
Why don't we turn the camera on to you three? I mean, after all, it's Jose's birthday. That's a good thing. Paid a lot of money for the camera. Oh, what am I doing? Hello. Jose, you're not in witness protection. It's okay. And was this one okay when we weren't using the calculator? For the most part. Okay, that's supposed to be the mark, right? We are going to do a lot of horizontal slices after the break. We're going to do all the things after. And that trig
It's x minus cosine.
all
Or is it cosine?
sine, cosine, tangent, inverse, cosine.
From 0 to a? Well, from cosine minus 1? Cosine's the first, You have to do
That's one of the times you can check in. What? I said. Check with me. Yes, you actually did. No. I would have just walked right by.
What's the other interval? Yeah, from A to what?
Can I see your graph? Okay, so what's the region that we're trying to find?
Yeah, it's the top low.
Okay, in the first quadrant, enclosed by cosine of x, y equals x, and the y-axis. So that's a problem. Where's the y-axis? Right, the y-axis is vertical.
Because it's also bounded by.
Because I am confident that you have the calculator skills and the brain power to do the work. But if you read it wrong, you're going to do it wrong. And you're going to be ready for it.
What is this? The little one? Oh my god, no. No! Yeah, that one, right? Yeah, that's what I thought too. Yeah, told you. Then it's, yeah. I think it is that one thing.
First quadrant down the time.
Cosine x minus x.
What is it? You're looking at this first.
Yeah.
Curves and the y-axis. There's only one region that I see that's bound by.
And then the boundary.
I think it's 0 to 8.
Right. Because what they're saying is it is bounded by just those.
But then don't you have to move
No, you don't.
Okay.
You just
That is, for lots of students, that's the hardest part, is figuring out what is the region that we're talking about. That's why I always tell everybody to shade it, you know, do something, get a little sketch.
I think so. Maybe it's better to show you put them equal to each other.
Because that's not by the y-axis.
The good thing about this is all the skills are good. You're going to use the calculator every okay, so like this one. It is this is not going to be charged. I will show you this time.
That would be A, right? And then what do you say? So it just goes on top of the
Y equals negative x, decreasing line.
Okay, yeah, I got it.
Okay. And I definitely, especially when it comes to calculator. Graph. Graph. Y percent squared, y clear, so what do you need now?
Yeah, I noticed that too.
So it'll be all of this?
Sebastian too. It was great. Hi. Me.
What function did you guys use first? X squared, right?
You got DD right too?
Is it squared minus?
It's the same integration, so you and just say it's the same thing as x squared plus.
Yeah, that one don't
Plus 1 goes up 1. Plus 1. X squared plus 1.
Number 2, calculator.
It's 14.
The dy integral, that's going to be the tough one. But really, it's the exact same conversation. You're just, instead of going this way, now you go this way. Okay? Good luck, keep going. I can't believe I said good luck.
Yeah, it's
Trust this one. Yeah, thank you. You don't have that calculator. That's my calculator.
Did you make it go from 2?
Negative 2.
you can take off.
Well, let's get the numbers.
Y is 6. Oh, it's F of X. Careful. Why does it have
Big ears.
That's not a number, that's a
The intersection point, that's only intersection.
No, like, there's,
I was like, and I didn't want to get that. In that, right?
Oh, no. Wait, it can't be used, it goes from
Okay, what number are you guys working on? What number are we working on?
Are you kidding?
Here, I'll try to do that.
If you are still working on number 2, I'm going to ask you to stop working on number 2. You should focus on 3, 4, and 6. 3, 4, and 6. Yes, sir. Sure.
You got D, right?
So y equals x squared plus 1
Yes.
is a parabola that you should x squared plus 1 is a shift. And I want the region bounded by y equals x squared plus 1 line. All the stuff underneath the line and above the parabola.
So that's right.
This is how I graphed it. Oh no, she did. No, I did wrong. No, I did wrong.
How did you graph this?
Y equals x squared minus 3. I know, it doesn't matter. I don't think it does matter. I think it does. No, it's above or below. I plugged it in, I know that. They both intersect at 1, 1.
No, it's 5 minus x squared plus 1.
No, that's
Look, this is the first one, right? 5 goes first, so it'll be like
I hate those kind of and 3. 1 and 3.
I got 5.
I just did the box.
that's how I think about it.
start at 8. Like top right and bottom, right?
X equals 1 and x equals 3.
Oh, you were doing horizontal slices. If you're doing horizontal slices, it has to be y.
Subtract x.
Right. It has to be one or the other. Vertical slices, everything is in terms of x. Horizontal, if we could, no, it's not notation. If we could have integrated the thing on the right, the vertical slice, we would get 8.5. But the problem is we don't know right now how to integrate the on the right.
I kind of grasped
I
it.
got it.
That's what I think it is.
All right, friends. Couple of things. Number one, I need you to please put your name on this paper. We didn't get quite as far with this as I wanted to, so I'm not going to pick this up for grade. Okay? But here's the thing. I need this as this is going to be the first problem set after spring break. Put your name on it. Leave it in the middle of the table. Otherwise, if you take responsibility and you put it in your backpack, everybody knows what's going to happen. It's going to die. Yes. Okay. So here are the answers. Number 1, C. Number 2, D. Number 3, D. 4, D. When in doubt, my last name is DeRozier. Go for it. 5 is C, and 6 is B. Now, 2 super quick things. Number 1, make sure your name is on it. Leave it in the middle of the table. Quick thing number 2. There are 2 dates that I need you guys to know about when we come back from spring break. One of them is Saturday, April 23rd. That is the date for the AP benchmark exam here at Southwest. It'll be from 9 a.m. until 1 p.m. You might just want to jot this down somewhere. Especially those folks that work, please let your boss know now. You're giving them like 5 weeks notice. Saturday, April 23rd, 9 to 1. This is your final. There is an AP summit. The calculus teachers from across the system, we're getting together on Saturday, April 16th to review important topics, to offer all the support. It's happening at Brays Oaks. That one's optional. Saturday, April 23rd is not optional.
You said 1 to 3?
They're both, I think, like 9 to 1. Okay? Have a great break. Make good decisions. I will think about you all. Oh gosh, oh so much.
How's your wife?
I can't even think about the word for how much I'm going to think about you all. So much. How's my wife? Thank you for asking.